Today is our Advanced Networking webinar. It's part of our Educational Networking series, our Network Essentials series. For those of you who aren't familiar with this series, we also have a beginner and an intermediate course, which we offer, and we do have recordings on. So we offer these on a regular basis. This is our advanced course. If you're not familiar with Ihiji was established in 2009. Hopefully you've heard about us. We've won several awards over the years, including Best New Product when we launched, as well as the CE Pro and Commercial Integrator Best for the category. We have, since they've created the category, been the brand leader for remote network management services within the CE Pro 100 as well. So hopefully everybody's familiar with Ihiji and what we do. I mentioned this before we started the webinar, but this is meant to be an educational webinar. So we are not going to be getting into Ihiji pricing, Ihiji product demos. It is meant to teach you networking principles. So it's meant to be an educational webinar, not a commercial. So if you're not familiar with Ihiji, if you would like more information, please go to our website, ihiji.com, and on that you'll see a form. You can schedule a demo, and we can do a demo on demand at your convenience typically. So just give us a call. It can be a 15 minutes demo. It can be an hour demo, whatever you need. We can accommodate you. So if you're not familiar with it, go ahead and schedule a demo at ihiji.com, and you'll get a walkthrough. Before we do get started, though, I want to let you know what Ihiji is so you understand how it fits into everything we're going to talk about. Ihiji Envision is a remote network management solution. It's designed to allow you to detect, diagnose, and resolve a lot of your common network problems more efficiently and more cost-effectively. Also do it all remotely. So it's simple, it's secure, it's cloud-based, low cost, easy to deploy, easy to set up, and something that, again, if you're not familiar with it, I would encourage you to learn more about it. So I want to start by talking about a very basic network, because this really starts to get into a lot of the topics we're going to talk about today. If you look at this network, there's not a lot to it, right? There's a modem, a router, an access point, Sonos receiver, and an Apple TV. Pretty straightforward. But if you look at this picture and start to think about the support challenges here, it really looks pretty complex. Because if your customer calls and says, I can't watch Netflix on my Apple TV, where do you start? And if you've been on our webinars, you've heard this before, but think about it. Is it a problem with the ISP? Is it a problem with the Wi-Fi? Is it a problem with the router, the switch? Is the Apple TV locked up? Is the iPad not working properly? Is the user hitting the wrong button? Is Amazon, is Netflix down? Those are the types of things you need to troubleshoot in that scenario, and it's becoming a more and more common scenario. Without the proper training, which is hopefully why you're here today, and knowledge, and without the proper tools, troubleshooting that installation remotely is nearly impossible. And then when you look at what's happening in our world, the growth of the network, things are becoming much more complex. It's not just an Apple TV and a Sonos, but it's 5 Apple TVs and 3 Sonos or 4 Sonos plays. Nest thermostats and multiple iPads and control processors and cameras and lighting systems and IP phones, and everything sits on that network, meaning that support challenge becomes even greater. And this is why I hope you're here today, is to learn how to support all these network devices in this world of growing complexity, because this is not changing. If you look at today's average ISP connection, in our world, the average U.S. household download speed is about 7.5 megabits per second. For round numbers, I'll go ahead and use 10 megabits per second, because that number is a little old. Now, if you think about bandwidth requirements for commonly accessed services, Netflix is probably the most common. Netflix recommends 5 megabits per second per stream of available bandwidth for that user. So if you think about the average U.S. household at 10 megabits per second, that means they can reliably stream for the best quality 2 streams at any one time, which in a lot of homes isn't enough, which is why we have higher broadband bandwidth services now with 20, 30, 300 megabit, even higher to gigabit. But I want you to keep these numbers in mind, because that 5 megabit per second number is key to understand. And if you look at the numbers above that, it kind of goes on to say, well, they recommend 2 megabits for standard SD video, 4 megabits for 720p, 5 megabits for what they call 1080 or best quality audio video experience. That throughput has to be available on both the ISP, but also has to be delivered over your local area network, both wired and wireless. And we're going to talk about that later, so remember those numbers. But if I look ahead at the future and I talk about some of the trends, this is where things really get interesting. Because I showed you those two slides earlier, one showed like 5 devices on that network. The other one showed about 25 devices on the network. On average, at Ihiji, we see 20 to 25 devices on our dealers' networks for every one of their clients. So that's pretty typical. Now, if you look forward to 2020, the number of devices is expected to increase 5-fold, meaning that your jobs that only have 5 devices will have closer to 20 or 25, and your jobs that have 20 or 25 will have 100+ devices on those networks. If you think about that challenge, it becomes very daunting. Now, in tandem with the growth in the number of devices in the network, we're also going to see a growth in broadband connectivity, and you're seeing it right now. A lot of markets now have 300 megabit service just starting to hit the market, so Dallas, New York. Most of the major metros now have this available in certain neighborhoods. And that's going to change quickly. The other thing you're seeing is the growth of gigabit internet, which is 1,000 megabit per second speeds, which is, do the math here, so 100 times faster than the average US broadband household connection today. So when we get to gigabit speeds, that's going to enable new services. That's where things become really interesting, because what that does is enable things like 4K streaming services to the home. A 4K stream requires 20 megabits per second per stream, and that's compressed. So you've got these two things happening. You've got the growth of the connected devices and the growth of broadband connectivity, which is going to put more and more strain on your networks. Now, when we talk about gigabit internet, a lot of guys say, well, that's probably years away. I don't have to worry about that today. And the biggest thing I want you to take away is you do have to worry about this today. By the end of this year, by the end of 2015, all 50 states are expected to have residential broadband to gigabit network services available. It's coming to cities large and small. Here's a list of the announced cities and the current cities. So this is something you need to start preparing for today. What this is going to allow for is things like 4K streaming, which we talked about earlier. And what I want you to think about is the bandwidth requirements for 4K. Bandwidth requirements for 4K are 20 to 30 megabits per second per stream. So if you've got 2 or 3 streams simultaneously, you're at 100 megabits per second pretty quickly. What that does is put a big strain on your local area network, because most of you are installing routers that only have 100 megabit max throughput, which is what I want to talk about in a minute here, is how you put the right infrastructure in place. And then the other thing what I want to talk about really quickly is there's a lot of debate around net neutrality, and things go back and forth, but this is something for you guys to pay attention to, because it will affect your ability to deliver and support your clients. Because if net neutrality is in play and the ISPs are throttling connections and the client's not getting what they expect out of your networking equipment, they're pointing the finger at you and not necessarily the ISP. So when you are seeing debates on net neutrality, pay attention to what the latest and greatest is and know what's best for you and your customers. A great way to do a gauge of the ISP connection, and this was even more important when people were throttling, is to look at this Google Streaming Quality ISP test, which you can run in your networks and see like time of day performance for your ISPs. This is a great report, but if you just Google Streaming Quality ISP test, you're going to be able to look at the averages across different ISPs in your network, look at the time of day and how those vary on those networks, and get some really valuable information. And they do this by mining data from things like YouTube, which they own. Now, I want to talk a little bit about high-performance networking and how all this comes into play here. We talked a lot about ISP speeds, but I think it's really important to pay attention to the performance of your local area network as well, because your client could be paying for gigabit internet and have the best networking equipment in the world that can deliver gigabit all the way through to the endpoints, but if there are things affecting performance in the network, they're not going to be getting the quality they need. In our industry, we're known for selling quality, speakers, video, so I wanted to find a few things. Packet loss is the amount of information that makes it to its destination, or is lost in communication, so that does not make it to its destination. Latency is the amount of time it takes for information to flow across that network. And jitter is basically the variance in latency. So if I was testing latency, I should expect consistent latency results. So if I'm pinging something, something should be coming back at 1 millisecond, 1 millisecond, 1 millisecond, 1 millisecond, not 1, 5, 10, 1, 3, 5, 10. It shouldn't vary by a factor of 10. So you should see very little jitter on your networks. But the two numbers I want to pay most attention to are packet loss and latency. Because if I look at these numbers on my local area network, they're going to have a huge impact on the available throughput. And this is kind of an intermediate topic, so I'm going to breeze through it. And if you want further clarification, I would encourage you to watch our intermediate network webinar. But basically what it says is that if I have 0% packet loss and 0 milliseconds latency, my theoretical throughput in a 100 megabit network is 94 megabits per second, roughly. But if I introduce latency, that number quickly drops. At 30 milliseconds of latency, my throughput is now to 16 megabits per second on my local network. And if I introduce packet loss into the picture, it becomes even worse. To the point where if you have 2% packet loss and 90 milliseconds latency, you're getting less than 1 megabit per second of throughput, which means your customer cannot stream quality Netflix video. That's not going to get through. It's going to be buffering. It's going to be choppy. It's going to look horrible. And again, the best ISP, the best network equipment, the best service isn't going to solve that problem because their throughput's just not getting there. Now, the one thing I will really encourage you to do is pay attention next time you're at a job site. Run some ping tests on your wireless devices, because more often than not, our Apple TVs, our Rokus are wireless because they're installed after the fact. And wireless is notorious for latency and packet loss with bad signals. That's where your throughput's getting crushed, but those are the devices that need the bandwidth the most. So just a great handy chart. It's on our website as well under our blog. It's called Latent Latency. So that is the performance side. So I want to talk a little bit about how you can gauge this performance. Number one, you can run ping tests, which is an intermediate topic, so I'm not going to talk about it today. But that's going to tell you a lot when it comes to packet loss and latency, and that's why you want to pay attention to those numbers. If you're getting high packet loss and latency, you need to pay attention to those things because it's crushing your user experience. In the customer's eyes, yes, everything may be working, but in reality, things aren't working well. And we're professionals. We're getting paid to make sure things are working well. They shouldn't be hitting the volume up button 3 times on their iPad for it to raise the volume 1 notch because 30% of their data is getting lost in the network. They shouldn't be waiting for things to buffer because they're paying for high-quality networking equipment. So those are the things you want to look at. But beyond that, you also want to look at basic things like what's the ISP doing for the customer? Is it providing consistent and reliable connection? One easy answer to that is run a speed test. If you go to speedtest.net, you can run a free report. If you log into Envision, you can also get a report on speed tests, which we run 4 times a day. So the first thing you want to look at is the internet speed test and your pings and make sure everything's lining up. Now, a few things you need to do today, and this is why I said that this gigabit internet thing is something we need to pay attention to right now, is prepare by selling the proper equipment. Because if I'm installing equipment that does not support gigabit throughput, that means that next year I'm going to have to go back to that customer when Google comes through with Google Fiber and say, hey, by the way, we need to replace all that infrastructure you just bought last year. They're not going to like that. So when your engineers are specifying your networks, starting immediately, they should be selling equipment that's sufficient, which means their routers have to be gigabit capable. When you're looking at your routers and looking at its throughput, there's actually a specification that all of them provide that say this is the max throughput with no firewall, this is the max throughput with the firewall turned on, this is the max throughput with stateful packet inspection turned on. And those are 3 different numbers. You want to make sure those numbers are going to meet your demands. So ask your manufacturers for those specifications and make sure your routers are capable of supporting that throughput. The other thing you can look at is Tolly, T-O-L-L-Y, provides independent testing and will publish throughput information on a lot of these devices. And this is for routers and switches. So that's a really great third-party report, which I like to look at. Obviously, your router, if it's capable, you need to make sure your switches are gigabit. The good news is most of you are probably installing gigabit switches. The bad news is if you installed a gigabit switch 5 years ago, there's a very good possibility that it will still need to be replaced because switches have what we call a switching capacity or backplane capacity, and that's basically how much processing capability it has. So you want to look at your manufacturers and see what its switching capacity is, because a 24-port gigabit switch doesn't necessarily have the capability to provide 24 streams of gigabit data. It's got a limited switching capacity, and basically what it comes down to is the more you spend on the switch, usually the better the processing capability is, therefore it can support higher throughput. Again, this isn't necessarily as important with modern switches, but if you go back, like I said, to older jobs where we installed a gigabit switch 5 years ago, In that case, you may have purchased a 24-port gigabit switch that may only have a backplane capacity of, say, 8 gigabits per second. And in that case, you may consider, especially if they're doing IP cameras, upgrading that switch. The other thing you should be doing, if you're not already, is installing managed switches. When you look at all this complexity and trying to troubleshoot and understand what's going on in your jobs, having a managed switch in place is key. Not only does it give you information like what ports are on and off and online and offline, what they're synced up at, but it also shows you packet analysis information, so you can see if a certain port is having a lot of errors or drop packets because of a device on that specific port is problematic and taking the rest of the network down with it. You can identify that information on a managed switch. So the ability to get added visibility is really important, and that's why we highly recommend managed switches. You can also take the managed switches in the PoE world and do power cycles, which is another added benefit. And finally, your Wi-Fi needs to be overhauled. With gigabit, Wi-Fi obviously is a concern, so there's 802.11ac meant to address that. Just quickly on this, there are two different flavors right now of 802.11ac. There's a Wave 1 and Wave 2. Both of them they require different hardware chipsets, so they're not backwards compatible. Wave 1 was the first wave. It's quickly been replaced with Wave 2. Not all manufacturers currently have Wave 2 products. So if you are installing 802.11ac, know that it will likely be outdated very, very quickly, and Wave 2 will replace it. Meaning your customers who are purchasing 802.11ac Wave 1 should only be customers who are early adopters and understand the fact that they will likely have to replace all of their hardware in the near future. So make sure you're selling Wave 2 if your manufacturer has it available. If they don't, find out what their upgrade plans are. A lot of them will have like trade-in promos and things like that. And then you just need to make sure you educate your customers. So the next topic I want to talk about is a pretty hot topic in our industry. It's VLAN considerations. VLANs are a way of segmenting traffic for reliability, but also for security. And they're more and more commonly seen in the residential world, especially as we scale our networks. So I'm going to talk about when you do want to use VLANs and when you don't. There are certainly times where you don't want to use a VLAN. And these are when it's not required, because there's a lot of added complexity in both configuration and the support of a VLAN network. So that adds costs and complexity to the picture. So if the client's network doesn't require a VLAN, don't necessarily configure it unless you absolutely have to. It's probably a good idea to install equipment that's VLAN capable. So routers and switches, so that if you ever need to add a VLAN in the future, you can easily do so. But it doesn't necessarily always make sense to configure a VLAN because of that added headache. So if there's a low budget installation or if it's just not necessary, don't do it. But if it's a large network and you're running out of IP addresses usable in that space, you may need to expand to multiple subnets. That's where a VLAN would make sense. If you're doing HD streaming cameras plus streaming video from Netflix plus control system and Kaleidoscape, that's where you want a VLAN. If you're doing guest networks for security, a guest network is usually VLAN'd out, so it separates the guest traffic from the house traffic. So those are the times when you want to use a VLAN. If you're getting into VLANing, physical documentation becomes really, really important because a lot of the VLANs are configured on a port-based VLAN configuration, meaning if I plug a device into port 5 of the VLAN, that port 5 is assigned to VLAN 1 or VLAN 3. If I plug it into port 8, it may be assigned to VLAN 2. So having the ability to quickly reference that is important. So I'm going to take a minute to talk about good documentation. This is what a starting point for good documentation looks like. You need to start at the physical level, and that includes all of your ports, what devices plug into it, what the cable ID of the cable plugged into that port is, what VLAN is associated with it. Is it PoE? And if it is PoE, what's the draw? Because most of us know that there are limitations on PoE on switches because they have a power supply that can only support so many watts. Right? And as you add more and more devices, the capacity of that power is diminished. So you want to make sure you're tracking how much you're using so that you don't have problems when you get to the point where you're maxed out. So this is what an example of what good physical documentation would look like. Obviously, you want to document your WAN information. This is a great example of how dealers are documenting WAN information. Who's the ISP? If they've got a primary and secondary, who's the primary ISP? What's their contact information? And who's the secondary ID? What's their contact information? You should document things like account numbers because you guys are the ones expected to support that. DNS, things like that should all be documented here. And then we're going to get down into the LAN information. Really, really important that you take the time to document all devices and their IP addresses. And I would also recommend that you segment your network so that all of your networks look very similar. So no matter what job you go to, all of your switches live between 10.0.0.2 and 10.0.0.15. And all of your access points live in the 10.0.0.230 to 10.0.0.245. Those are the types of things you need to document. I'd also take the time to document things like MAC addresses and physical locations, model numbers, and manufacturers. All this information is going to be invaluable when you're trying to troubleshoot a network of 50 devices remotely without rolling a truck. And lastly, something you are probably getting more familiar with but hadn't thought about 6 months ago is how in the world do I document all of these services? Because all of a sudden I've sold a Sonos receiver and I've sold 3 Apple TVs to this customer and something died, and now I need to go back and reconfigure and replace everything. But when I initially set up Rhapsody and Pandora and their iTunes and their Netflix and their Amazon Instant, I had all those usernames and passwords, but all of a sudden they're gone. You want to think about secure ways of documenting all the services which they use and their credentials for those. So this is something to start thinking about as well, and I'll talk about password documentation really quickly. If you're doing all this, you're storing important credentials for the customers where they're vulnerable, and you're probably saving VPN credentials and access control information and IP camera information. You want to be sure you're storing all this information securely. So look into password management tools, 1Pass, LastPass, KeePass. Those are things you need to start using for your customers. Other things you can take in consideration if you really want to go deeper into security is two-factor authentication using Google Authenticator or Authy. That's just another added level of security. But I strongly believe that our industry doesn't take security seriously enough. It's something that everybody knows we should do, but not a lot of people are doing well. So if you are not, or you're thinking about it, these are some tools to start at least investigating and looking into. And we've been using LastPass here for years and really like it. So definitely something to consider, especially as you are expected to support the customer's iTunes accounts now. And that is becoming a more and more common expectation. So changing gears a little bit, what else are you guys able to do for support, especially in this world of connectivity? Something you should definitely be thinking about is remote reboots. If you're not doing this today, this is something you should be doing, using IP PDUs. So working with SNAP AV or APC or Panamax and putting in PDUs is really something you should be focused on. Doing soft reboots of devices. There's no reason you have to drive out and reboot a control processor because it's running slowly. Just log into that thing and issue a soft reboot command, and you'll free up some memory or clear that hanging process, and things should be running smoothly again. If they're not, it's probably time to upgrade that control processor. And then the other one, which we talked about, is PoE, port control. Don't take the whole switch down. Get a switch, a managed switch that's PoE capable, and power cycle individual ports by turning the PoE functionality off for that port and back on for that port. So now you can reboot things like access points and control processors and IP cameras. There's a lot of cost savings in remote reboots, and it's really easy and inexpensive to do. The next thing I want to talk about is some secure remote access methods, or different remote access methods from the least secure all the way through to other secure tools. Port forwarding, SSH tunneling, VPNs, screen sharing tools, the Connect Ninja. There's a lot of different ways to talk about remote support and do remote support, so I'm going to talk through some of the more common. The first is port forwarding. Port forwarding is not the way to do remote access. It's very commonly supported. It's been done a lot of times historically for your customers, but you should stop doing it immediately for all new installations. Consider going back to all of your existing clients, doing a security audit, and giving yourself the opportunity to turn all of the existing port forwards off. It's what's exposing. It's probably the biggest exposure to hackers your customers have in regards to their home network and their home automation equipment. because port forwarding is very, very easy to hack and to get through. It's very, very common. There are ways to expose those port forwards really easily. You can go run a port scan at the site right now for free. The good news is that's something you can charge for. I can send out a letter to my 500 customers and say, hey, we're offering a new service. It's a network security audit. And it's a $500 value. I'll come out and do it for you for $99. It's a good foot in the door. It's a good upsell opportunity. You can run a speed test while you're out there. You can look at the routers and the switches and see if things are due for an upgrade. And you can also run a port scan to disable all those port forwards you put in place. So get away from doing port forwarding for remote access. Now, a lot of you are saying, well, if I'm not doing port forwards, how do my clients access the system? And how do I get to the program and change the program remotely? There are plenty of other ways to do it. The most powerful way and the most common way, and especially in the IT world, is through VPN. VPN is very, very powerful, very common. It's not very complex to set up. It's widely supported across especially commercial grade and better routers. The challenge with VPNs is the management and ongoing management of that. Most integrators share a username and password for your router across client sites. Some of you have a company-wide VPN username and password that apply to all routers. Those are both bad practices. The second, if your VPN credentials are the same for every single job, if one of your technicians leaves and isn't happy, they have access to every one of your client sites. And to go back to those 500 routers and change the username and password every time a technician leaves isn't realistic. So my recommendation is continue using VPNs. Use it on all your installations, but don't give the credentials out to anybody except for your IT admin. And everything that requires VPN access should be escalated to that one person. And get out of the habit of using the same username and password for all of your sites. Get out of the habit of using things like LastPass to track all these usernames and passwords. And limit who has access. Use other tools for your programmers. Create a VPN account just for your customer so they can access their cameras, but don't give that to anybody else. That's the right way to do it. There are other things you can do with VPN to keep it more secure. You can use pre-shared keys, which I highly recommend. If you want to take it one step further, you can use certificates. Consider the mobile needs of your customers. If they're trying to access the VPN over their mobile phone to do the cameras, then you need to think about what type of VPN you choose. Always use security encryption in your VPNs. Consider two-factor authentication. Think about if they want to do things like host an NVR internally, think of cloud applications which you may be able to use. And then educate your users on why they need to take this extra step to get to their cameras and why that's important, because without it, their cameras might be exposed to the internet, and that wouldn't be a good thing. The other way to do it, which I'll talk about real quickly, is the Ihiji appliance. The Ihiji appliance, you basically plug in behind the router and the firewall, so it's secure because it's blocked from the outside world. And Ihiji has a feature called the Connect Ninja, which gives you secure remote access through our appliance and to those devices. And when you do this, you're getting a on-demand tunnel. It's a temporary tunnel. It's logged, so you can see exactly what technicians are accessing what device. And you can delete technicians from Envision, and they no longer have access to those devices. So the Connect Ninja is a really, really easy way. It's an easy replacement to port forwarding, and it's a much more secure replacement of port forwarding. It's your solution to not giving your VPN credentials out to every single programmer and technician because they just use Connect Ninja. And that's how you can reserve those rights for your IT admin. So the Connect Ninja can be used to do things like remote desktop, because it's basically any TCP port, any single TCP port on any IP device can usually be accessed to the Connect Ninja. So you can run remote desktop. You could run VNC to your touch panels or your Mac computers, which is really handy. You can do SSH to your control processors, emulate commands, or check firmware information, all through SSH, all through the Connect Ninja tunnel, really, really easily. This doesn't require a lot of thought or training. Another one is you could do log into your power management devices and change your auto reboot because we can access web interfaces. And even this is one of the ones I like. If you need to make a VLAN change, you can log into your switch through the Connect Ninja, change that VLAN, and be out within just a few minutes. So those are some use cases for this. The other thing while we're on this topic that you want to think about is increasing your visibility into what's going on. So having the ability to look back at history and see what happened at certain times a day. Is this device falling offline 3 times a week, or is it just once every 3 months and it's intermittent? If there's a pattern to it, what's causing that pattern? Are there other devices that are having problems along those same timelines that may correlate? Are they all sharing the same switch? That's what visibility means. You can get to the root of the problem. You can see what's happening over time. If you're getting into remote monitoring and management, the way you can get extended visibility beyond just online, offline, and network performance information like ping information is through protocols such as SNMP. So I'm going to take a few minutes to talk about SNMP. This is definitely a more advanced topic, but it's becoming more and more common. SNMP stands for Simple Network Management Protocol. It's a standardized protocol, but it's not a standard. It is also not simple, even though the name says it. But as you get comfortable with things, it's really important to know these different acronyms, which you'll probably see. OID stands for Object Identifier. And OID is how you get access to certain pieces of information on the device. So if I want to see, for example, temperature, and that device supports it, there would be a number assigned with temperature. That's like 0.1.3.15.22.12.13. Some really obscure number. But if I query that number with an SNMP utility, I should get back a value, like 75. And if I check the OID in the manufacturer's MIB, or management information base, I should be able to correlate that number to something like temperature, and I should be able to see that temperature is reported in degrees Fahrenheit. So if I query that OID at that obscure number, I'm going to get back 75. If I check the MIB, I'm going to say, okay, well, that's actually the temperature, and it's 75 degrees Fahrenheit. Or if I want to know what information my manufacturer supports, I will call that manufacturer or check their website and say, hey, I'm interested in monitoring your devices using SNMP. Do you support it? If they say yes, I'd say, great, where can I find the MIBs for that device? And they'll say, well, just go to this link and download them. And then you can download that MIB and look through it and find something like memory, or find CPU utilization, find firmware information. Those are the pieces of information that are helpful when you're supporting your customers remotely. The MIB will then tell you what OID to query. Use an SNMP utility. You can now get that information out of that device. It's reliable, it's lightweight, it's widely supported. That's why we really like SNMP. One note on SNMP before we get too far into it. Just because the device is capable of reporting information doesn't necessarily mean you should monitor and obsess over it and get notified on it. Pick and choose what information is most important, because when you get into SNMP and you are starting to do SNMP walks in devices, you'll notice that there's more information that you ever care to know that's reported. Literally, you can run an SNMP walk, which is basically a way of looking at all the SNMP information available on a certain device and get back 2,500 different values of information, of which maybe only 5 pieces of information really matter to you. Other things to look at with SNMP are RFCs are basically they're agreed upon ways of accessing information. So managed switches, 90% of managed switches support a certain RFC that will tell you what bandwidth is being used across ports, or what ports are synced up. Interface administration is a great example. So those are standardized across manufacturers. If they support the RFC, that's great, because especially in switches, if they support the RFC, there's a base level of information that switch is now able to tell us. SNMP comes in a different number of flavors. There's version 1, there's version 2C, and there's version 3. In our industry, and for what you guys are doing in particular, in the residential world, 2C is probably the most common. Version 3 wraps more security around it. It's usually used in the enterprise world, so you don't see that as often. To access information using version 2C and version 1, you query the device directly, but you also have to have what it calls a community to access that information. And most devices have a read and write community. And what that is that just a different level of permission. So the write community allows you to affect change. So I can power cycle a port, for example, if I specify the proper write community and proper OID. The read community just gives you read-only information, so I can see, is that port physically linked up and there's power? Is there power being drawn from that port? That's what the read community would be. The communities, you can think of them as a shared password But usually the communities are standardized. Most manufacturers out of the box will, the read community is public and the write community is private. That's just a string, and you can always override it. So that's SNMP. It really grew out of the IT world. Initially, it was designed to monitor things like routers, servers, switches, printers, things like that, but it's definitely becoming bigger and bigger in the AV and Internet of Things space. So quickly, what's an SNMP configuration look like on a device? So I picked a Planet switch. And this is where SNMP becomes a little tricky, and this is where I can drop a best practice. A best practice is to pick your manufacturer and stick with that manufacturer in the networking world. There are subtle differences or drastic differences depending on the manufacturer model and the way things are configured. So if I go to Planet switch, configure SNMP, it's going to look very different than if I went to a Cisco switch to SNMP. And even within Cisco's world, if I went to a Cisco 2900 series switch, configuration of SNMP looks very different than an SG500, for example. So you want to get familiar with the devices and how to configure things, but this is an example of what you would look for on a device. A lot of times on a managed switch, the first thing you need to do is enable SNMP as a service because it's not enabled by default. What that does is turn it on. But once it's on, it needs to be configured. So you need to go and do the SNMP configuration and usually set your communities. So you're going to set your read-only and write communities. You're going to set sometimes your host to make sure that some devices have like an internal firewall and limit SNMP to just a certain host for security reasons. Less important in the residential world, but some of you may want to do that as well. So this is the Planet switch and how it looks. You would enable the SNMP service. Then you would go in and set up your SNMP community. You'd have to put in your community name. You'd specify public for your read group and private for your write group. And then enable it and you're up and running. So it's not very difficult once you learn how to do it. What does get a little more confusing though is how do I actually utilize it? SNMP walk is the most common way to get information. SNMP walk will basically go and query all the SNMP information on the device and give you a dump. And the first time you run this on a managed switch, you're going to be blown away by the amount of information it reports. It literally will give you, hundreds of lines of information back. So an example of how you would use SNMP walk, the first thing you need to do is generally download it, and it's a free tool. But this is what it might look like. SNMP walk-C for community public. It needs to match what's configured on the switch. The next thing is -V for version, and we're using, again, 2C. And then you need to specify the IP address of the device. So in this case, 172.17.22.116. When I do that, I'm going to get back all this information. And it's going to be in the command line, ugly format. It's going to be very difficult to sort through and very difficult to understand, but it will open your eyes to what the world of SNMP looks like. Once you've done that, I would save yourself some headaches and go to ireasoning.com, and there's a great free for non-commercial use tool that you can start to at least play around with to learn. It's called the MIB browser. It's basically a graphical interface into SNMP walk. So again, you specify the IP address, you do a walk on that device, you'll set up the community information, and it'll spit it out in a nice graphical interface so you can actually sort through that information. Now, I mentioned that there's a lot of information available through SNMP, so you want to know what you're looking for. The next thing I would do once you've figured out what the device supports, and it does support SNMP, is check those MIBs and really think about what's important to you. And the types of things that might be important to you is bandwidth used. How much bandwidth is that device using? Are there any errors on the ports? Are there any drop packets on the ports? What's the processing utilization on that switch? Is it being overburdened? How much memory is on that switch and available? Is there a memory leak or memory issue? How much PoE consumption is on the switch? What's the temperature of the switch? All that information can sometimes be found through SNMP. Now, I say sometimes, and I want you to really pay attention to that. Not all devices support SNMP. Certain devices provide a lot more information about themselves. And generally speaking, the more you pay for a device in the networking world, the more information you're going to get. So in an entry-level Cisco switch or a Linksys switch, let's use Linksys. On a Linksys entry-level switch, you may be getting firmware information, uptime information, and switch model and manufacturer. That may be it, 3 pieces of information. Not very useful, somewhat useful, but not very useful. when you go up in the SG500 or SMB line of the Linksys Cisco switching, you may be able to get a lot of port information and PoE draw out of that switch, and a lot of other information, but as far as usable, helpful information, that may be about it. But then when I go to my enterprise grade Cisco 3500 series core switch, I'm going to get things like temperature, and not just temperature, but maybe intake temperature, exhaust temperature. I'm going to get fan status on every one of the fans on that PoE switch. Is it functioning properly? I may get PoE draw. I'm going to get processing information. I'm going to get memory utilization. The point is, as you go up in the line, you're going to get a lot more information from those devices. And it is generally your job to figure out what's important. And those are the types of things I would pay attention to. The other thing I will say that is, if a device does not support SNMP, you can leverage your manufacturer and say, hey, I'd really like you to consider this for future firmware upgrades or future products that you develop so we can have better insight. And if the device doesn't support SNMP, it doesn't mean you shouldn't monitor it, because there's a lot of value in seeing network performance information, and all that's measured through a ping. That latency and packet loss that we talked about earlier is key, because when a switch is overburdened, when there are packets and errors in that switch, that's when you see network latency and packet loss. So if you're measuring that information, you can a lot of times see that information, and then you can log into the web interface and correlate the logs. So just because it doesn't support SNMP doesn't mean you shouldn't monitor it. One of the things Ihiji really does well is helps you sort through what information is valuable. So this is a screenshot of a switch. We create simple protocol profiles for a lot of devices to say, okay, this is what we know about that switch. These are the pieces of information that are important to you. So we really try to help filter that information. A few things: if the device isn't profiled with an Envision, it doesn't mean you can't monitor it. You can also always add those OIDs manually and then copy and paste that profile around to different sites. And then if the profile doesn't have a piece of information you want, you can always, again, go in and add that OID manually and get that extended information. One thing I do want to educate you on is the Windows world also has a standard. It's a Microsoft standard, so I don't know how standardized it is, but in the Microsoft world, there's a protocol called WMI, Windows Management Interface, which is basically Microsoft's version of SNMP. So if you're talking to the IT world, you may hear that term, and I want you guys to be familiar with it. What it means to you, if you are doing IT services for your clients and you are managing servers in their home, you're managing some of their computers, you can turn on WMI, and using Ihiji, you can get some light information like disk space, memory, is a process running, things like that. So it's just helpful to know about. The next topic I'll talk about is NMAP. And to kind of tie all this together before we go down the NMAP path, I talked about port forwards and how insecure they are. And I talked about how easy a port forward is to exploit. The reason it's easy is because of tools like NMAP. NMAP is a tool for IT security to do investigation on devices. So a few examples: I could run a IP scan using NMAP and get all of the IP addresses that reply to ping. And then I can expand that and say, not only do I want ping, but I want you to tell me what open ports are available on the device. So all of a sudden that person with a quick and easy free tool has exposed all your port forwards. Okay, that's great, but they still don't know what's behind it, right? Well, NMAP also has a host identification layer where it can take an educated guess into what device is behind that port. It says, well, this is a Linux device that's running this version of software, and how long has it been up, what OS information do we know about it, and all of a sudden they've got a lot more information on the device. And then that user can now go Google this device and say, oh, well, this is a Linux device with this version. I know that version is susceptible to this software hack, and try to hack into that device. It took them 5 minutes to do that. If that device is a camera system and you didn't do the firmware update and there's some sort of vulnerability on that software version, now they've got access to your cameras. So NMAP is a really easy free tool which you can download. This is it's called ZenMap. It's a Windows-based interface for it. But it'll do things like I just said, identify the host. So this is an example of a host, and actually this is an IP scan with several hosts, and this one happens to be up. It's running Linux version 2638-30, 100% accuracy. MAC address information, the number of ports it itself has open. So a lot of information exposed through NMAP. You can use this as well if you don't have documentation on your networks and you're trying to figure out what's going on. Here's another one, a quick scanner device. I can see exactly what, if I run this against a certain IP address, I can see exactly what ports are open. So this is a quick scan of well-known ports. On this router or device in particular, SSH is open, HTTP is open, VNC is open. A lot of information for somebody who's trying to potentially gain access to your systems. They can run it across broad swaths of networks. So they can run a network scan across your entire neighborhood and see what of my neighbors who's replying to ping and what ports are open. And they're going to get information like what the manufacturer and model in some cases are. So that's a tool I want you to be aware of and understand how easy it is for people to use that against you, but also understand you could use that tool to help do network investigation. Getting towards the end, one of the things I want to talk a little bit about is DNS. We, in a lot of cases, see DNS not being used properly. So a lot of people will set up their DHCP servers and not specify a secondary DNS server. The way DNS works for domain resolution is there's a primary and a secondary. And a lot of times those DNS servers are localized to provide for faster DNS queries. So there are high-level DNS servers that are run by companies like Level 3, Verizon, AT&T, and those are like, there's one or two of them in the country. And then that information is replicated down to regionals, and that information is replicated down to ISPs, and that information is sometimes replicated into municipalities like Austin, for example. So that if I ever need to query a DNS server and I live in Austin, it'll go to the Austin server and not to Washington, D.C. to get that information. So it happens a little faster. The problem with those local Austin servers is they're not meant to be as reliable or highly available, meaning they're meant to fail. And that's why we have a secondary DNS server. So that if that local server is ever down for maintenance, it falls over to the secondary and the user doesn't notice any interruption in service. So it's always good to set a secondary DNS server, and I wanted to talk about a few different secondary DNS servers you can use. The two I would recommend are Google and OpenDNS, and here's the IP addresses for them. But always make sure you're setting your secondary DNS servers. 4.2.2.2 has become, it was a crowd favorite, but unfortunately it's become increasingly less reliable, and I wouldn't recommend it at that point. So if you're using it, I would consider changing that. While we're talking about this, there's also an opportunity to add a value-add service to your customers. OpenDNS does provide for an additional cost parental control capabilities and phishing protection, because now it's able to filter all those URLs that customers are entering. So you could offer that as a service to your customers. A few other tools that you might find helpful. If you go to dnsstuff.com, there's a bunch of free tools you can do to run like pings, query information about an IP address. So I can look at an IP address and see where in the world it lives and what ISP it might be coming from. So if you notice in a log that somebody's trying to hack your camera system, I can run an IP information and see probably that's coming from Taiwan. And then I would turn off that port forward. You can do your DNS lookups here and check DNS servers. You can run WAN port scans and look for all of your port forwards that you might have forgotten to turn off. So DNS stuff is a cool site with some free tools that you can run. And then, it's kind of to wrap up here. We talked a lot about this concept of network management and maintenance, and one thing I will point out is it does get complicated. And when we talk about all these different tools and manufacturer-specific tools and knowing where to start, it can be intimidating. So one of the things Ihiji really does well is we consolidate this information to a nice single pane of glass is a good way to think of it. So I can get one snapshot of everything that's going on, and then if I do need to launch manufacturer-specific tools, I know where to start. I can say, well, this is it looks to be a problem with a switch, so I'm going to log into that switch now, and then I'm going to investigate further. But it'll help you make your job a lot easier with all this complexity and the increasing complexity. So if you're looking at all these tools and saying, well, why do I need a tool like Ihiji or something similar? That's exactly why, because managing a dozen or more different tools becomes a headache, even if it's just for basic power management. So quickly, I'll kind of talk a little bit about how Ihiji does it. We look at connectivity issues, we'll look at power problems, we'll look at ping information, so we'll look at packet loss and latency. We look at SNMP information. We go through proprietary protocols and look at things that aren't available via SNMP. We provide for IP power management, full remote access, everything we've already talked about. What it's meant to do is make your service department more profitable, more proactive, and more efficient. It's meant to save you guys truck rolls, and the level of complexity that's and the number of devices which are hitting our networks and are going to hit our networks over the next few years is insane. I mean, if you look at how many devices are going to hit your networks and how many new services you're expected to support, all that without proper tools and training is not, you can't sustain. So you need to look at new ways to provide service to your customers. Rolling a truck for every single issue and every reported symptom and troubleshooting on site and spending hours on site trying to replicate problems doesn't work going forward. So that's why you need to look at some of these tools and get familiar with these tools and play with these tools and start to use them to your benefit. Really quickly, we do a lot of education around recurring revenue. We've kind of pioneered this concept for the AV world over the last 5 years. So I'm going to end with some things on this, because I think it's really important to understand that you guys are growing your core competency and growing your knowledge base and should be able to raise your rates. You shouldn't be paid like electrical contractors. You're now IT guys. You just happen to be in the home. And IT guys get paid more, so you can raise your hourly rate, but they've also done a really good job at monetizing their knowledge and their services. And this is really, really important, because a lot of the devices you're installing now are consumer grade. You make 10 points margin and not 60 points. So you need to find new ways to make money. So it's really good to start to think about how you can monetize your service offering and look at recurring revenue. We've got a lot of resources that help you do it, but in a 2-minute pitch, this is what I would focus on, is focus on a managed network offering and focus on everything I just talked about. None of those things should be given to your customers for free. They should become something you offer your customers on a recurring basis as part of a subscription. And as part of that subscription, they may pay $29 a month, and they get access to remote reboots, Wi-Fi monitoring, ISP monitoring, local area network performance tests. Those are the type of things that they'll happily pay $29 a month for, but you're also saving yourself time, money, and headaches at the same time. So again, I told you I'd keep this at 2 minutes, but this is what it might look like. At a basic level, all of your customers may be willing to pay you $5 a month to do a network speed test and tell them when the internet's up and down, because the internet to your customers is as important as a glass of water anymore. So $5 a month for a $70 a month service is nothing. That's their starting point, but then you may say, for $19 a month, I can actually monitor some of your devices and make sure that your control processor, your Apple TV, your switch, and your access points are all functioning properly. And by the way, certain devices I can reboot, so I'm going to go ahead and reboot those, and I'm going to monitor your Wi-Fi to make sure your access points are up. That's only $20 a month. Again, most customers are willing to pay that. If you get into your bigger networks, you can look at expanding your services and saying, we're going to monitor more than just a handful of devices. We're going to monitor anything that's critical to system performance. And I'm going to do everything I told you I was going to do before. And then if you get into preferred for $50 a month on your very large networks, we're going to do as much as possible to manage everything remotely. This is a service that's required of all of our commercial grade networks. So this is a really, really easy way to start earning recurring revenue on every one of the networks you sell, and just start getting paid for all this expertise and all this extra service you're providing your customers. So with that, I told you there was a lot of information to get through, so I kept this at just about an hour. I appreciate everybody's time and attention. If you have any questions, I'll happily stick around and answer them. I think I answered a lot of the questions as we went through the webinar. And if you haven't seen our beginner and intermediate courses, I'd encourage you to watch those as well. They talk about a lot of the topics we kind of hit at a very detailed level. They get into some high-level information on those. So. All right. Well, I'm going to go ahead and say thank you to everybody for attending. Hope you had a great day. I appreciate the time. And if you have any questions, please email us or give us a call.